In the 2015 relative velocity question, we're given this diagram. A and B travel along two straight roads, which angle at an angle of 135. I'm making this one here 45. B is going to continue up in this direction, which is negative positive. Car A is moving towards the intersection at a uniform speed of 60 kilometers an hour, so the velocity of A is just 60 in the I direction, nothing in the J direction. The velocity of B, when B is going, you can see if we take this as the origin, B is going negative positive, so the velocity of B is equal to negative, and we have as 45, negative 45 by the cos of the angle, and plus 45 by the sine of the angle in the I direction and in the J direction. Cos of 45 is 1 over root 2, so we get minus 45 over root 2 in the I direction plus 45 over root 2 in the J direction. The velocity of B. We were asked for the magnitude and direction of the velocity of B relative to A. The velocity of B relative to A, as you all know, is the velocity of B minus the velocity of A, which in this case is minus 45 over root 2, and it's going to be minus this 60 here, minus 60 in the I direction, and just plus 45 over root 2. And I'm going to decimalize these look a bit awkward, but this is the velocity of B relative to A. And this is minus 91.82 in the I direction, plus 31.82 in the J direction. I'll just jump back up here to magnitude. So the magnitude of the velocity of B relative to A, the square root of 91.82 squared plus 31.82 squared. On a calculator, 97.2. What are we dealing with here? Kilometers an hour. Kilometers an hour. And the direction, theta, is equal to the inverse tan of your y over x, or j over I, 31.82 over 91.82. So theta is going to give me 19.11 degrees. So let me just do a quick sketch for the direction here. We can see that A and B, so we could draw when A is here, B is here. We can say the velocity was negative, it was negative positive, so negative positive up in this direction here. So that will be north of west, north of west. Second part, shortest distance. Okay, well, we have A getting to the junction and then moving in this direction, and B being here, and that's 2 kilometers. So just draw your line where the velocity of B relative to A was. So we have A and B, we have our shortest distance, and this is the angle that we got. This theta is the direction that it was moving in, going in this direction. So bring that theta back into the triangle here, and we'll get the sine of theta is equal to x over 2. So 2 sine 19.11 is going to give me 0.6547. Now that's in kilometers, so that will be 654.7 meters. So 655 meters is if it's to the nearest meter. So anytime you get these shortest distance, do your diagram with your velocity of B relative to A, or whatever, one relative to the other, and create your shortest distance diagrams. The easiest way to do these.